and welcome to this intro for your final experiment in this series to practice using your new advanced higher uncertainties and data gathering skills. We are going to do a traditionally quite higher level experiment, but we're going to be carrying it out using that advanced higher level of knowledge and understanding. So we are going to be measuring G using the ball drop experiment. So I'm just going to do quite a short title and a longer aim. And the purpose of this video, guys, is just to make sure that everybody's clear on what measurements you should be taking, the kind of analysis you'll be doing, but the actual experiment itself really should be done on spreadsheets. So we're using that digital data tables, using the spreadsheet formulas to carry out all of your uncertainty calculations and your processing of data, and also your graph, and using the linest function. So that's really what we want to be looking for in this one. So our aim to find the, what's shaking here? Acceleration due to, sorry if that's that shaking noise is coming across, due to gravity on Earth. Sorry, it's driving me nuts. Where is it coming from? Oh, it's my actual clamp stand that's holding my iPad. Sorry, folks. Okay, so let's have a little look at some initial analysis. And this analysis skill that I'm about to do is one that you practiced a little in higher, particularly for your assignments, and one that you need to get a lot better at this year. So the relationship that we're going to use to be able to find G today is one of our equations of motion. And we can pop this equation of motion into the form of y equals mx plus c, and that will allow us to see if we measure certain aspects of this equation, certain quantities, we can see how they'll relate to each other and what our gradient might look like, and if we'll get a straight line. So y equals mx plus c, so s is y, and then we literally just swap these two around. So our m is a half a, our x is t squared plus ut. Okay, so there is our y, there's our m, there's our x, and there's our c. Now, in the ball drop, our initial velocity will be 0. So we're going to be plotting these two values, and the gradient should therefore come out as a half m. Okay. You could, of course, if you wanted, you could plot 2s, and then the gradient would come out immediately as a. It's totally up to you. That would mean you would have to have a 2s column in your data table. So just so there's no confusion, you are literally going to take a ball, but any object you can drop a whole bunch of times reliably and it won't break is absolutely fine. And you are going to measure the height of the drop, okay? And you are going to measure the time for the drop. And that's it. And we'll need to do at least 5 different heights of drop, and each one will have to be done at least 5 different times. I hope that these are two measurements, height and time, that you are capable of taking at home. I think timing is certainly something we can all do at home, no problem. It's totally up to you at advanced higher level how complicated you want that timing method to be. Perhaps you want to try and get rid of that human error aspect by using some slow motion video or some imaging technique to really get that time as accurate as possible. the distance, the height measurement, obviously a tape measure would probably be the best thing. So, you know, one of the one that you get in a toolbox or a flexible one, any one at all. The larger you can make the heights, the better. And remember, they do not all have to be equally spaced out. So you can have, you can do a whole bunch of different time measurements for some, you know, 5 relatively large heights. You don't have to go, you know, from like 20 centimeters up to 2 meters. You know, all of your heights can be above a certain height because that will make your timing better. If you don't have a measuring tape, may I suggest doing multiples of a known height? So try and get something that you know the length of, or the length is stated on it, and then just do multiples, drop from multiples of that. Okay. So try and be creative in being able to get these heights if you don't have something as basic as a tape measure. Perhaps if you just had a ruler, you could mark up a piece of string or something with multiples of that ruler, and so then you can do your heights that way. You're advanced hire. Get creative. Measure some heights. Measure some times. This is what we're going to be plotting. That is what we expect to come out. Your data table and graph should look very similar to the table and graph that we produced in our graphs and tables spreadsheet tutorial. All right, folks, best of luck, and I look forward to seeing your results. Thank you very much. Sorry for all the ums and ahs. I was super distracted by the shaking of my clamp stands. Comment below if you like my new yellow paper to provide better contrast.